Welcome to this explainer. You know, every time you open up one of those mind-blowing new apps, you aren't just talking to one single AI brain anymore. Today, we're going to pull back the curtain and look at how developers are actually stitching together multiple, highly specialized AI models to create these cohesive, incredibly powerful applications. We've moved way beyond your standard simple chatbot. Now, we're talking about intelligent, multi-layered systems that can literally reason, plan, and execute.
Okay, let's dive right in with the core question. How exactly does a single application leverage the specialized skills of several different AI brains without creating just an absolute logistical nightmare? Because it is a massive challenge. If you ever wondered how a modern app can seamlessly jump from generating beautiful creative text to crunching highly complex logic in the blink of an eye, well, you're in the right place. We're going to map out exactly how that invisible relay race actually happens. We're going to explore this in three really clear layers. First, layer 1, the big picture, getting a bird's eye view of how the internet connects these tools. Then, layer 2, the architecture, where we zoom into the nuts and bolts of a smart app. And finally, layer 3, the bigger idea, zooming way out to look at the future of automated, team-based AI. Let's get started.
Let's start simple with our first layer, the big picture. We're going to focus on APIs and large language models to lay the foundation for everything else. To really grasp the mechanics here, think of an AI application as a massive, bustling restaurant. The API, or Application Programming Interface, acts as your waiter. Now, as the customer sitting at your table, you don't just walk into the kitchen, fire up the stove, and start cooking your own meal, right? You give your order to the waiter. The waiter takes your specific request to the back-end kitchen, waits for the chefs to do their thing, and then brings the finished response right back to your table. Without APIs, securely passing data back and forth in a common language, modern apps simply wouldn't function. They are literally the essential messengers of the internet.
And just like a high-end kitchen relies on specialized chefs, a pastry chef, a grill master, a sous chef, modern AI apps need different large language models, or LLMs, to handle different tasks. Think about it. If you have an app processing hundreds of thousands of simple, routine requests every single day, you definitely don't want to use an incredibly expensive, heavy-duty model for every single query. That would be a massive waste of money. Instead, you use a lightning-fast, cheap model for the simple stuff and strategically route only the really complex logical reasoning to your expensive model. It's all about using the right brain for the right job.
Okay, let's step into layer 2, the architecture. We're going to see how this actually works behind the scenes. And to make this concrete, let's imagine we're building a smart travel planning assistant from scratch. Before modern routing tools existed, developers were forced to do things the old way. Let's say you wanted your new travel app to use 3 different AI models. Well, you had to manage dozens of isolated API keys, totally different environments, and separate billing accounts. It was tedious, fragile, and honestly, an absolute nightmare to maintain. Just one service changing its rules could break your whole app. But the new way, it changes everything. Developers now use a single, universal proxy layer to seamlessly route requests to absolutely any model they need. So, what is this proxy layer? Well, developers use platforms like OpenRouter. Going back to our restaurant analogy, think of OpenRouter as your head waiter. Instead of your application trying to establish individual, complicated connections with every single AI kitchen in town, your app only talks to OpenRouter. You just use one API key, one standard format, and OpenRouter securely handles all the secret handshakes with dozens of different models in the background. It's a real game changer for building versatile apps fast.
But connecting to an AI brain is really only half the battle. You also have to strictly control it. To make sure our travel assistant behaves, we have to establish the crucial difference between a system message and a user message. The system message acts as a strict set of guardrails. It defines the AI's core persona entirely in the background. So if a user suddenly asks our travel app to write a Shakespearean sonnet or diagnose a weird rash, the system message steps in like a bouncer and says, "Nope, I am only an expert travel assistant." The user message, on the other hand, is just your everyday literal request.
Let's follow the journey of a single text prompt just to see how all these pieces fit together. From the exact moment a traveler hits enter with their request, the app instantly attaches those essential, invisible system guardrails. Then the OpenRouter proxy takes that combined package and routes it to the perfect, specialized LLM for that specific task. The model processes the data under those strict rules, generates a response, and sends a beautiful, structured itinerary right back to the user. It all happens in literal milliseconds, but the coordination behind it is just incredible.
Finally, let's zoom all the way out to layer 3, the bigger idea. We are entering bleeding-edge territory now. This is where we shift from building simple, single-task chatbots and look toward a future driven by automated, multi-agent AI systems. Because not all models are created equal, understanding model selection is absolutely vital. Routing matters immensely. A single sophisticated app might need creative reasoning, mathematical logic, and fast execution all at the same time. If you want high-end creative reasoning, you're going to pay a premium. But if you just need a quick summary of a hotel review, you want the lowest cost possible. Developers have to carefully orchestrate the right brain at the right time. For a startup handling millions of queries, choosing the wrong, expensive model for simple tasks can literally bankrupt the business.
To manage this intense level of complexity, developers rely on orchestration frameworks like LangChain and LangGraph. If OpenRouter is the head waiter handling communications, think of these frameworks as the kitchen managers. They provide the logical canvas that orchestrates the handshakes between entirely different AI agents. They basically allow different models to reliably pass structured data to one another, collaborating on massive, multi-step workflows without requiring any human intervention along the way.
Let's see how this multi-agent collaboration actually builds in reality with our Rome trip. In a system powered by these frameworks, you aren't just sending one isolated query and waiting. You're triggering an intelligent chain reaction. Agent 1, which is optimized for web research, finds the cheapest flight routes to Rome and passes its data to Agent 2. Agent 2, optimized for high-volume data processing, summarizes thousands of hotel reviews and passes that data to Agent 3. Finally, Agent 3 synthesizes all that complex data into your perfect, fully customized Italian itinerary.
This is a profound, fundamental paradigm shift in how we interact with technology. We are moving far past the days of simply talking back and forth with a single generative model. Look at where we're heading. You're essentially managing an entire automated team of AI systems. These are agentic systems, dynamically and autonomously working together, passing tasks back and forth to execute incredibly complex goals for you. You become a manager of digital intelligence.
Which leaves us with this final, provocative thought. We now know developers can seamlessly route queries to specialized brains, wrap them in strict guardrails, and chain them together to work entirely autonomously. So, as these multi-agent frameworks become the new standard, what massive, real-world problems will you tackle when you can orchestrate a dozen brilliant AI minds at once? Thank you so much for joining me for this explainer. I really hope this gives you a completely new perspective on the architecture driving tomorrow's AI. Keep learning, and I'll catch you next time.